Lately, I've been hearing a lot of talk about the latest artillery system, the Tu-43 Malva, which is supposed to be Russia's answer to the Western Archer, Caesar, and other similar wheeled artillery systems. At first glance, it looks like the Russians have made a decent debut in a field that's new to them. A reliable Bar Z8X8 base, an impressive range of 1000 kilometers, and a notable 7 shots per minute. But what can the Malva actually offer in terms of firepower and mobility compared to its Western counterparts? Or will they easily blow the Russian newcomer to bits, wiping their high-tech feet on it? As always, let's discard propaganda from both sides and try to get to the heart of the matter. The Tu-43 Malva. First off, we should say that Malva isn't really a new development, but a rebranded famous tracked self-propelled artillery M100C on a wheeled platform. What types of howitzers are there? First, there are towed howitzers, caliber 152mm, like the well-known Tu-A36 Gayazint B and Tu-A65 MSTA-B, which are transported by a tractor. Second, there are self-propelled ones on tracks like the Tu-S19 MSTA-S or the Tu-S3 Acacia, which are usually called self-propelled artillery systems or SPGs. Both the tracked and the wheeled versions have difficulties with deployment time, transportation, and speed of leaving positions after firing. They should either be gradually phased out or used in a stationary manner. The wheeled Malva can fully replace them. However, traditional tracked self-propelled guns are more versatile, we must admit. They offer better crew protection, larger ammunition capacity, and better mobility. The Malva, however, is cheaper, has a significantly longer operational range, and its chassis is more durable. It has lower maintenance costs and higher speeds on highways or solid ground. That's its secret. The concept of element is that of mobile artillery on a branching network of roads or nearby. So, it's just a perfect addition to the AMA tracks, no? Even the command understood this bright idea, apparently realizing the role of highly mobile artillery systems in modern conflict. On one hand, time has been lost, but on the other, admitting mistakes also means correcting them, which is why they started developing the Malva system quickly. An artillery system on a wheeled chassis is cheap and effective, and if desired can be produced in large volumes, which has always been the key to the success of the Russian army, no matter what it's called. The downside is some technological backwardness. You can laugh and point out the specs all you want, but this is only temporary until there's too much Malva, which I'm sure will cause problems for the opposing side. So, the recently adopted Tu-43 Malva belongs to the third type of howitzer, which is now being called a self-propelled artillery piece, or SP. But what does it actually represent in terms of fire capabilities? As I have already mentioned, Malva is equipped with the well-known tracked M100S or towed M100B 152mm Tu-A64 gun. This is a gun with a barrel length of 47 calibers. The longer the barrel, the faster you can accelerate the shell and the farther it will fly. So, practically all of Malva's competitors have a 52 caliber barrel length. However, this was a conscious decision. No one was planning to invent and produce a new barrel. The goal was to create our own artillery quickly and with minimal costs, ensuring its operation was cheaper than the tracked version. At least this barrel is rifled, just like the British pride, the Challenger 2 tank, which means if we believe the Brits, the shooting accuracy should be spot on. They wouldn't simply praise their rifled gun for no reason, would they? Hence, considering its larger caliber, advanced muzzle brake, and semi-automatic vertical wedge breech, the Malva is at least as good, if not better. But that's just a minor detail. The Brits love to boast about their tank's cannon, so why not use their own arguments? The rate of fire is stated to be 7 shots per minute, but there is an interesting nuance here. Malva uses a separate casing loading method with a mechanism for delivering shells and charges. Simply put, the crew needs to run around the vehicle like Energizer bunnies with drums on their backs to ensure the claimed 7 shots. The shells have to be manually fed from the center of the highway directly to the gun, and each shell weighs 43 kilograms, with the casing alone weighing about 11, and these segments are arranged diagonally. The designers seem to have a bit of fun by placing the ammunition on the right side of the chassis, which has to be delivered to the loader on the left side of the weapon. Conversely, the casings are on the left side and they are loaded from the right. Convenience and automation. In the Archer, the crew is chilling and relaxed because they have an automatic loading system, and sitting in an armored cabin with air conditioning, they're not breathing in gunpowder gases and aren't risking their lives from counter-battery fire, nor are they running around their setup like ants. That's why the crew is just 3 people compared to 5 in the Malva. In Caesar, for instance, there's a semi-automatic loader. It's like a robotic arm that manually loads shells from the ammunition rack into the gun. That said, the crew is also 5 people here. They just have a bit less running around to do. Basically, the plus side of Malva's charging system is that it simply doesn't exist. Simplicity in a word. By the way, the entire artillery section of the Malva is like this. At the rear of the chassis, the upper carriage mount with aiming mechanisms is open. It provides firing within a front sector width of 60 degrees, with elevation angles from -3 degrees to +70, and horizontal orientation within 30 degrees to the right or left. Underneath the artillery system, there is a foldable spade that transfers the recoil impulse into the ground. Here, like everyone else. And now, the most interesting thing, the firing range. It directly depends on the type and sophistication of the ammunition they got from the enemy. The inventory includes high explosive fragmentation shells of various modifications, but besides those, you can also use smoke, cluster with fragmentation or cumulative fragmentation elements, jamming shells and high-precision Krasnopol shells. So, the maximum firing range with a high explosive fragmentation shell is 24.7 kilometers. With active-reactive, it's about 29. Caesar can shoot a simple high-explosive fragmentation shell at 30 kilometers, but with an active-reactive shell with a gas generator, it reaches 41. The Excalibur, with a gas generator and folding fins, flies at 46 to 49 kilometers, and active-reactive shells using a combination of a gas generator and a rocket booster can overcome all 55. But we don't take the latter into account, because Krasnopol might be the same overall. Well, in the Archer, we have an overall identical range of shots, but I want to mention that the distance depends not only on the gun, but also on the shell. A longer barrel naturally has more space for acceleration, and if a more aerodynamic projectile is used, it's just perfect. As I mentioned, we immediately discard projectiles with attached rocket motors, as those are already half shell, half rocket. Overall, as you have probably guessed, modern NATO projectiles have much better aerodynamics. Similarly, it must be said the Russian army already has them, but they were designed for Coalition SV, and their serial production is only just being established. This is basically the reason for the Coalition's inactivity. But if the subsequent production of shells becomes massive, then using these on the same MST, Hyacinth or Malva will lead to a significant increase in shooting range. I assume a regular high-explosive shell will fly at least 2 to 3 kilometers further, making it already 27 to 28 kilometers, while an active-reactive one will add 5 to 7 kilometers, making it 34 to 36 kilometers. Yes, it still falls short of the Caesars, Archers, the Polish-Czech variety, and the 3-axis, but we at least have some competitive numbers now. The third reason for the shorter range of Soviet guns is the volume of the charge chamber. NATO examples have a volume of 23.25 liters compared to 16 liters in the Soviet 2A64. On the one hand, this is due to the smaller caliber, and worn-out gun chambers tend to expand, leading to lower pressure and reduced shell speed, which affects range. On the other hand, the larger the chamber initially, the more gunpowder can be packed in, creating higher pressure and making the shell fly further. But again, this leads to more wear and tear, which is why NATO guns become unusable faster. And this dependence between range and chamber volume is not linear, as other factors come into play, like smaller calibers, which need smaller charge chambers to achieve the same range. Nevertheless, I'll point out that all these features have been maximized in the SV Coalition. There's a 23-liter charge chamber and a 52 caliber barrel length while maintaining the caliber at 152 mm. This was enough to earn the title of Queen of Artillery, but as I mentioned earlier, it's still not mass-produced. However, Rostec stated that the maximum firing range of the 2A43 Mallow exceeds the declared characteristics. They did not specify by how much. In the video description showing the use of the self-propelled gun in the Kharkiv region, the Ministry of Defense made a note that things are not that straightforward. This is probably a reference to the recent statement by the deputy head of Rostec about the significant increase in the firing range of the Mallow and the ongoing active work in this direction. On the show, Voyenaya Priomka, they mentioned the figure of up to 45 kilometers. Well, with a jet engine, Krasnopol can potentially achieve that. It can even reach 50 kilometers now, so you could say they weren't lying, and then we'll see. But where Malva really wins over NATO weapons is in durability. High-tech capabilities often result in poorer reliability and endurance. NATO SPGs in the toughest operating mode are designed for about 50 to 100 rounds per day. The Ukrainians, used to Soviet weapons, fired 300 times. The loading mechanisms and barrel couldn't handle it, and in a week or two, the howitzer is off for an expensive repair abroad. For Caesar, the ideal rate is considered to be 40 rounds per day. And even then, in less than a month, the barrel's lifespan would be completely exhausted. With Archer and others, it's more or less the same story. The MST, which has a similar gun to the Malva, can fire 100 times in just 1 hour, and the total barrel resource is over 2000 rounds, that is, at least twice as much. Preparation, getting the gun into position, and packing up before leaving take minimal time, about 1 minute. For comparison, the Swedish Archer, a benchmark for wheeled self-propelled artillery, sets up and packs up in 30 seconds. The French Caesar takes 60 seconds to set up and 40 seconds to pack up, so it's roughly the same. The ammo load of the Mallow is 30 shells, 12 more than the Caesar in its 6x6 version and equal to the 8x8 version. The Archer has 21 shells in its automated loader, and another 20 can be stored in the reloading chassis, making it quite competitive. Yes, the Archer is the champion of speed and range. In 14 seconds, the artillery can fire 3 shells and leave the position even before they reach the target. However, it's important to understand that technology costs money and time. Only 48 Archers have been produced, and of these, 10 were given to Ukraine. Last year, there was information about another contract for Europe for another 48 units. The armed forces of Ukraine apparently had 26 units on a 6x6 chassis and 17 on an 8x8 base as of early 2024. In total, 350 units have been produced. The cost of one Archer ranges from $4.5 to $5 million, while a Caesar costs $4 to $4.5 million. There is no official data on the Malva yet, as it is still a new system in production, but presumably at least 50 units have already been produced, as there have been at least 2 deliveries to the troops, and the price of one, I believe, hardly reaches even $1.5 million, since the cost of one MSTA, which is inherently more expensive, is $1.6 million. In other words, it is quite possible that Malva's price does not even reach 1 million, as it is a simplified wheeled version of the tracked Mista. That's why Malva stands a good chance of overwhelming the competition not with quality, but with quantity, which historically Russians have always been better at, and they are already in serial production. And yet, the lower cost did not prevent Malva from being equipped with everything needed for full-fledged shooting in the 21st century. Navigation, a digital fire control system that calculates firing parameters for any type of ammunition, ensuring quick and precise topographical adjustment and targeting. Targets can be programmed even before moving into position, then just drive to it, set up, fire off rounds, pack up and leave. There is also a simultaneous barrage mode. The fired shells fly along different trajectories and hit the target almost simultaneously. The method is not only good for the synergistic effect from several outages, but also for reducing the time spent on setup, thereby decreasing the likelihood of counterattacks. So, it's quite a dangerous weapon and shouldn't be underestimated, or even worse, mocked. And lastly, the main thing that distinguishes the Malva from the MSTA is the wheel chassis. Here we have a 4-axle all-wheel drive vehicle with high payload capacity from the Bryansk automobile plant. BZ6 6127 Voskina, equipped with a Yaroslavl diesel Yams engine producing 470 horsepower. It allows the fighting vehicle weighing 32 tons to reach 80 km per hour on roads with a range of 1000 kilometers. It's worth mentioning that Caesar and Archer are lighter than Malva, at least in version 6x6. However, I don't understand the fuss about this weight difference. Better off-road capability? I don't think so. And if it's needed, it's better to use a tracked vehicle. Or is it that the fact that Western self-propelled guns are mostly built on civilian dump truck or tractor chassis gives them any specific advantages? Not likely. The suspension is independent torsion with hydraulic shock absorbers for each wheel. As for the ground clearance, it's essentially tank-like and reaches almost half a meter. Do you think it will have poor off-road performance? The Malva was built on the base of a serious traditional army truck, considering that later it could be fitted with a heavier gun from the Coalition SV. The Malva has a range of 400 kilometers more than the Caesar, though it doesn't make much difference. However, the wheeled version is a quarter lighter than the tracked version of the MSTA, allowing it to be transported in the cargo hold of an Ilyushin 76 aircraft, despite being about 13 meters long. To reduce weight, the Malva's armor was only left on the cabin. The vehicle is not intended for frontline work, plus mobility requires simplifications. Practice has already shown that the armored cap can handle it, having once withstood a hit from the M30A1GM LRS missile launched from HIMARS. However, if the crew was caught while shooting, they might have had a hard time, but nothing was said about that. The biggest threat to equipment working from the near rear, of course, are drones. Special mesh screens are provided for protection, mounted at a certain height above the vehicle's body. I think the field engineers have probably even welded full-fledged grills onto their Malvas. In summary, here's what should be said. Don't forget, Malva, as a full-fledged howitzer on a vehicle chassis, has opened up a previously unseen opportunity for the Russian army. Exactly! Speed up the relocation of equipment and move faster between positions where the surface allows it. The wheeled chassis exits dangerous areas quicker and accordingly avoids retaliatory strikes. For urban operations, wheels, not tracks, are a must-have. Plus, the wheeled concept allowed for a reduction in the number of people per weapon. For instance, the Mesta required 8 people, whereas the Malva only needed 5. Another big advantage of the 2S43 system is its high level of compatibility with existing equipment. The artillery part of SMSS uses chassis from the Bryansk automobile plant, which are also widely used in the Russian army and have a lot of operational experience. Only a few components and parts are developed and produced from scratch. These design features significantly simplify and reduce the cost of production and operation. Whatever anyone says, the 2S43 Malva, despite some technical lag, positively affects the potential of the Russian Federation artillery units. They have all the necessary advantages, as we have already seen. There is no doubt that the Malva will become an effective addition to existing self-propelled guns. And to those who straightforwardly hate this technology, feel free to skip this video. Anyway, thanks everyone for watching. Don't forget to like and subscribe. Hug everyone, and see you soon in new videos.